So we're continuing with probability today. Now today's going to be a little bit more challenging because we're going to be using our counting techniques to find out the number of ways something can occur. Last class when we did probability, it was stuff that we could, like for dice, you could just look at the table I gave you to find out how many ways something can happen. Or you could just draw a picture of marbles in a bag or something because you just count it. But in this case, what we're going to be doing, the options are so big, you're not going to be able to just draw a diagram anymore. We have to use our counting rules we've been using to figure out how many ways it can happen. All right. We're also going to move on to talk about two other things called compound probabilities and complements at the very end. So before we get started, we need to talk about what dependent events are and what independent events are. Dependent events are two events in which the first event has an effect on the second event. So let me give you a quick demonstration. Suppose that I have a deck of cards, right? And I draw a card out, right? What are the chances? Let's just say, what's the chances of it being an ace? Well, how many aces are there? And there's a total of 52. So there's a 4 in 52 chance that I'm going to draw an ace on the first draw. Now I'm going to do another one. I'm going to keep that ace, put it in my pocket, whatever. And then I'm going to draw another card. What are the chances of that one being an ace? 3 out of 51. There's only 3 aces left and a total of 51. Now look what happened. That first choice, what did it do to the number of options available for the second choice? It lowered it, right? So did my first choice affect the number of outcomes for my second choice? Yes. So the second choice depended on the first. The number of options for the second choice depended on the number of options I had from my first. All right, now I'm going to change it a little bit. Let's say that I'm going to go ahead and draw an ace out of a deck. There's a 4 out of 52 chance, right? Now instead of putting it in my pocket, let's just say I put the card back in the deck, reshuffle it. Now what are the odds of me getting an ace? Still 4 out of 52. Since I put it back, did the first choice have any effect on the second choice? No, it didn't have any effect at all because I put it back. That's called independent. So independent events are two events where the first choice has no effect on the second choice. Okay, so we're going to go ahead and look at this first example here. And we're going to find out, are these events dependent or independent, and then we're going to give a little explanation as to why. Okay? There's no solving needed here. We're just going to categorize them as dependent or independent. So, suppose a cookie jar has 10 Oreos and 8 chocolate chip cookies. And here comes our first event. I reach in and I take out an Oreo cookie. So what are the probability of getting Oreo cookie there? 10 Oreos out of a total of 18 cookies. 10 plus 8 is 18, right? So that's my first choice. That's my first event. Now, after I eat it, I reach in and I engage in another event. I take out another one that's an Oreo cookie. Now what are the odds that that was an Oreo cookie? There's only 9 Oreo cookies left and a total of how many left? 17. Now, did I lose an option in the event or the sample space? Yeah, I lost an option in both. My first choice reduced the number of options I had for the event, and it also reduced the total number in the sample space. So, are these events dependent or independent? Dependent. Okay, so I'm going to squeeze my answer on another. Well, I'll just put on another piece here. You guys might have to write yours off on the side on your note paper there. The answer to number 1 is dependent, and the reason is that we're going to put a reason. The first choice reduced the event and sample space, I'll put SS for sample space, of the second choice. So that's why it's dependent. The first choice reduced both the event and sample space. Okay, we're going to take a look at number 2. Now suppose you take an Oreo and you eat it. So we're still dealing with the same probability for the first choice. The Oreo's still 10 out of 18, right? So there's my first event. Then I eat it. Then I reach in and take a chocolate chip cookie. What's the probability of getting a chocolate chip cookie at that point? 8 out of 17. Now let me ask you this. Did my first choice, did that affect the number of chocolate chip cookies? No, because I had an Oreo, right? But, so, the event was not affected. But let me ask you this. Was the sample space affected? Yeah. How many total cookies are left? 17. So, it doesn't matter whether it's the event or the sample space. What matters is one of those things affected, the top or the bottom. And yes, the sample space was affected. I lost a total. So therefore, these events are still dependent. So for number 1, the answer was yes, because both event and sample space were affected. But on number 2, they're still dependent, but not for the same reason. They're dependent because the first choice reduced the event in the second choice. I'm sorry, not the event, the sample space. Okay, so let's go ahead and take a look at number 3 here. Number 3 says, now suppose you reach in and take an Oreo cookie. So there's our first event. What is the probability of getting an Oreo cookie there? Right. So, what's the probability of getting an Oreo cookie on that first try? It's still 10 out of 18, right? Nothing new there. But, notice the words here. Decide you don't want it and you put it back. And then you take a chocolate chip cookie. What's the odds or the chances of getting that? 8 out of 18. Now let me ask you this. I took the cookie, I put it back. Did that affect the number of... No. The number of chocolate chips? The answer is no. Did it affect the total? No. It didn't affect either one, and therefore, what would we say about those events? Those events are independent of each other. They have no effect on one another. So, our answer to that is the first choice had no effect on the second. We'll look at the last one. It's a little bit of a different scenario, but if we just stick to the definitions of what these things are, we should be able to get it. So let's say you roll a dice and you get a 6. What's the probability of rolling a dice and getting a 6? 1/6, right? There's 1/6 on the dice, and there's 6 outcomes possible for a probability of 1/6. Now, next you roll the dice and you get a 5. What's the probability of getting a 5 on your second roll? So let me ask you this. When you rolled the dice on the first time, did that affect your probability of getting a 5 at all on the next roll? It did not. You still had the same total, and you still had the same number of 5s. The first choice did not at all affect the number of options for the second choice. So therefore, these events they're independent again. Okay? We're not going to put a reason, because the reason's the same as number 3. Independent. All right. And I'll just draw an arrow to the reason for number 3, because it's the same. Now here's some for you guys. I'll let you guys play around with them, see what you get. Just all you have to do is tell me, are they dependent or independent, and why?